Okay, guys, so we're gonna get started. Today we're gonna be talking about Git, but just a couple of announcements first. In submitting find determinant, if you find that you're not passing the very last test case, the one that's doing the 5x5 again, this time with the 5x5, it's checking to see that you deallocated any, like you don't have any memory leaks, you don't have any undefined behavior in your program. So it won't like really show the output of what's wrong. But if you look under your history for that problem, you'll find a file that says like, grind results, actually tested 5x5 matrix or whatever. Look inside there, and then you'll have all Valgrind's like complaints about what I didn't like about your program. Go fix it so it's not complaining anymore, and then it'll pass that test case. Hopefully we'll also have time to talk today a little bit about Valgrind, so that you can use that in your programs to help you figure out what's going wrong. But Git first. How many of you guys have used Git before? Oh, very large chunk of you. So you guys can probably show me how to do things too, because I'm pretty new at this. So first thing is like, what is Git? It's a distributed version control system. A version control system is designed to help you deal with multiple versions of some project that might exist. It doesn't have to be a coding project, though a lot of people do use it for coding projects. You might have a book or a video or some like digital image you're drawing, and you might have like a different version of you want to do a little bit of tweak on this way or a little bit of tweak that way or try some things out without screwing everything up. That's what Git's designed for. It's distributed, and that means that everybody gets a full copy of the project as opposed to being a centralized version control system like SVN, so this means there's no single point of failure. Everybody has a copy of the project. And while you might treat one particular repository as like the golden master copy that's the real thing, right? Everybody does have their own full copy of the project. So some reasons you might want to use it. Have you ever wanted to like try out something in your program, but were afraid that the change might screw it up? Or you're afraid that this thing might not work and it's going to involve a lot of work, and you don't want to do that because you're afraid of what might happen? Or because of this, you're like, well, I'm just going to create a copy of my project, and I'll have version 1, version 2, version 3 folders of each different thing. Then you end up with like a ton of different ones, and you're not sure which is the right one anymore. Been there before. Or maybe you have been working on your project and you've introduced some new bugs, and you want to figure out where they're coming at, or you want to be able to go back to an old version where there were no old bugs, or wanted to be able to easily collaborate in projects with others. If you ever wanted to do any of these things, Git or any other version control system can help you out doing that. So you can get Git here. If you've already followed the Windows setup tutorial, you should already have it. It's probably not going to be the latest version, but it should be good enough. So once you have gotten Git installed and you want to go open a terminal and run the following commands, if you're in Cygwin, open the Cygwin terminal. These are just commands that are going to just set your name and your email so that when you do commits to a project, that information will be stored. You can also configure some other operations like how end of line is treated. Windows and Linux treat end of lines a bit differently. So if you want it to be like, you can have it so that like when you check out, if there are any like control line feeds, which is what Windows uses, they automatically get converted to regular new lines. And when you check in your work, it'll automatically, if you're on Windows, change your controlled line feeds to new lines. So you can do that. So if you want to enable Git and CLine, which is pretty nice, so you don't have to go outside of it, you go to File, Settings, or on Windows, or Settings on Mac, click on Version Control, click Git, and then specify a path to the Git executable. So we would just go over here. For me, it's File, Settings, Version Control, click on the drop-down arrow, go to Git, and then you need to make sure that this Git path is set, which it should be automatically. Also, if you're planning on working with GitHub, you can also set your GitHub credential information inside here, and then you'll be able to check out things from GitHub, from your private repositories, or push information up to there. So if you want to start a repository on the command line, if you want a new and empty project, you would create a new directory, go into that directory, and then type git init. That'll create a new Git repository. Or if you want to clone or get a copy of an existing project from like online, for example, somewhere on GitHub, git clone, and then on GitHub, you should be able to get a link to the repository, and then enter that in there, and it'll create a copy of the project on your own machine. On CLion, you go to VCS, enable version control, select Git, and then if you want to check out an existing project, if you go to the home start page, there will be an option to check out from version control, select Git, and then enter the URL. So I've created a new project over here, and I want to put it under version control. So VCS, enable version control integration, select Git, and it's now under version control. Just like that. So you might be curious about like, what is a Git repository? It's the files that make up the project that are being tracked by Git, as well as snapshots of those files at different points in time, as well as the history of the changes that have been made to the project. 2 and 3 are going to be kept inside of a hidden folder called .git. So you shouldn't be playing around inside there, but that's where that information's at. So if you want to add files to your repository, you do git add, you list the names of the files that you want to add, or if you're on CLion, you right click on the files and you can say git add, and then or Control-Alt-A. This will tell Git to start tracking those files, and it will also add any of the changes that you've recently made to those files to what Git is keeping a track of. So if you add a file for Git to track, you make changes to it, you're going to have to add it again so that Git has the most up-to-date changes. And then when we make a commit, take a snapshot of the repository, it's going to include those files. So if we go back over here, what I might want to include is my cmakelist.txt, which says how to compile it. And I might also want to include main. I'm going to right-click on those, go to Git, and then add. And those files are now being tracked by Git. No, I don't want to add .idea. So there are some like hidden files that are being used by the IDE, and we'll figure out how to ignore those later on. You can see that the color has changed in the files. The green means added, but it hasn't been committed yet. Red means that it's there, but it's not being tracked by Git. And Git will kind of like complain at you if you try to make a commit later on and you have untracked files in there. So we'll talk about how we can ignore those files in a moment. So if you want to make a commit, it's git commit. You can optionally add a -m after this and specify a message. Or if you don't specify a message, Git will open up the editor that you've set for it. You'll be able to type your message in there. It's recommended that in the first line, you put a very short description of what's happened, because if people are running some log information and they just want to see like a very brief explanation of what's happened, that will show up. And then you can do your long form description underneath. On the CLion version control commit, it will then take a snapshot of all those files. But there's some files I want to ignore first, so we'll talk about that before I make my commit on my computer. So again, there's some files that you want to ignore, but are actually still going to be inside your project directory. These might be things like the binary files you create, like when you build your project. They might be generated or temporary files that just get created as part of the build process, but they shouldn't be included for everybody else to be using, because everybody should have their own version of it. It should be generated. Again, Git will complain at you if those files are there. And you can create a file called Git Ignore, .git ignore, so it's going to be a hidden file, and then Git will ignore those files, and it knows that you don't want them. In a Git Ignore file, blank lines you can just use for separation. They don't do anything. Lines that start with a # are comments. An exclamation point in front of a pattern will negate it, so it says like everything but this, or don't do this one. A pattern that ends with a / will match with the directory with that name and everything inside of it. And then your regular shell glob patterns will also work. So if you do *, 0 or more characters will match. * is any single character. Or if you list some characters inside brackets, it's one of those characters inside that set of brackets. There's also some special ones that are like **. So if you have some pattern /*, it means everything inside that directory, absolutely as far down as it goes. If you do */ some pattern, it means wherever that pattern appears in any nested directory. So if you did like */ my file, that would mean anything that happens to be named my file in any of the directories beneath this one, far down as you go. And then if you put something in between, it means it'll do any number of directories in between A and B. So you have to start at A, then regardless of how far down A and B you have to go, or how far down you have to go into subdirectories, something whose name is B, and it will ignore those files. An example of some things you might want to ignore might be temporary files. Some editors will create temporary files that ends with a tilde. So this means, ignore everything so basically in all subdirectories, any number of characters that ends with a tilde, ignore those ones. Or if you want to ignore all hidden files, / anything that starts with a period followed by any number of characters. But you might say, well, I don't want to ignore my Git Ignore file, so not Git Ignore. Does that make sense? Yeah. Files with 2 periods? What's a file with 2 periods? You're talking about like .. Or you mean like file.tar.gc? Because ... just generally means the level above you. So when you specify like this Git Ignore file, it's based on this directory, and you can have multiple Git Ignore files and further subdirectories, and those rules will be like override any of the higher up rules that you want. But I'm not sure if I've ever seen a file that's like whose name is like a.b. So we're going to add a new Git Ignore file here, and then we'll make our first commit. So I want a new file .git ignore, and I do want to add it, so it's now being tracked. So one of the files the things that we don't want to track is anything inside cmake-build-debug. This is where by default CLion is going to create all your build files. And notice I made it with a / so it's the directory that has that name, not just a file. And I would also like to ignore the .idea folder. So there's a hidden folder called .idea. I don't want that one to be tracked either. I also don't want to track that desktop.ini. Any questions on what I have in here? Okay, so now I want to commit. That's Control K or version commit, ECS commit. So over here, it's going to show you you're going to select which files you want to add. So I want to add all these guys in here. And notice because of the Git Ignore file, it's not doing like the .idea folder or the cmake-build-debug. If I didn't list those in here, it would say, hey, do you want to include those? So this is my like initial commit. So that would be like, my title, also added .git. And then you can put whatever you want, like say to ignore something like desktop.ini, cmake-build-debug, and then I also wanted to ignore the .idea. Here you can put the author name. It says it can complete, but for some reason I think I was having issues with this. Like if I did my name, it's like it complained and wouldn't let me commit. So I'll try committing. If it fails, yeah, it failed. So for some reason, I'm not sure why. It's not letting me commit unless I... You can also do things before commit, like reformatting your code, rearranging your code, optimizing imports, blah, blah, blah. So for some reason, if I leave it blank, it'll let me go through and do it. None of those files have been committed, and I can come back to here at any point in time. Any questions? Okay. So some things that you might want to do is create a new branch. A branch is going to be like a new version of what your program is. A lot of times you're going to want to create a new branch if you are going to be adding some feature or making some significant change to your program. To do this, you say git branch, new branch name. Notice that it'll create the branch but won't switch you to it. If you want to switch to that branch automatically, git checkout -b and then the branch name, and then it'll create that branch and switch it to it. Again, it's a copy of the version of the project, starts with everything that you have. you're going to want to use a lot of branches in your code. Every time you think about adding something new or changing something, make a branch for it. Because if you like what you've done, you can go put it back into your main set of code. So let's go try to make a branch. So I might, if I want to make a branch, I go to version control, git branches, and I want a new branch. And maybe this new branch that I want to create is the Spanish version. I don't know. So I've now created this new branch and I've switched to it. You should be able to see what branch we're in if you look at version control. And now if I go over to like main.c, instead of saying like, hello world, I might be like, hola, hello, and say like hello world here, and it'll be like the Spanish version. And again, you could be making other changes, adding in more features, adding in more functions, doing whatever you felt like, adding in more files, and you can go from there. And then we can commit over here, and then this should commit to our, you can see that it's showing like, hey, here's what's changed. I'm cool. And then you can commit your commit message. So made a Spanish version. And then we could commit. So now I have two versions. And if I want to be able to switch between those versions, that's what the checkout command is for. You say git checkout and then what branch you want to switch to, or you go to the version control git branches and you can switch back. So if I go to version control git branches, I can switch back to master, checkout, and you can see that it reset my state back to where I was when I was in master. So I was able to go back to my old version. So I'm not losing anything when I'm doing this, which is a really nice part about Git. And one thing to note though is like if you have some changes that you haven't committed and you try to check out a different branch, generally, if I want to go like back to a Spanish version, it should say like, hey, you have some changes here that you haven't committed. It's not clean. And so generally, if you want to switch branches, your branches needs to be clean. Which you can do by committing the changes that you've made and then doing the switch. Or if you're like, well, I'm not sure if I want to do that, you can stash the changes, but that's a lot more complicated. Right now, it'd just be simple enough to just commit and then switch. If I undo, it would let me switch back to the branch. So a lot of times you guys are going to be wanting to work with each other, especially if a partner. And so we might want to have some remote central repository where we're both able to upload code there and we can make changes to it. One way that you might do this is by hosting your Git repository on GitHub. And like Git and GitHub, they don't have to be used together. They just very commonly are. They just use GitHub to hold that Git repository. So we have some common place of being able to pull code from or put code to so we can work together. But your own company might have its own like version of some server where they're storing their Git repository instead of using GitHub. So what we can do is we can go over and find GitHub, and we can say, hey, I want to create a new repository. And I might call this repository name like sample repos. You can make it public. Anybody can see this repository, so anybody can take from it, but you can choose who gets to commit. And private, only you get to choose who can see and commit. For this class, you want to use only private repositories for doing your homework. This is because you don't want somebody else to be like desperate and go steal your code, and then we think you're copying because someone has the exact code because it was hosted in a public repository in GitHub. Apparently this year, GitHub also allowed all repository or all users, whether you're free status or not, to have access to private repositories. But when you're signing up for your GitHub account, you can search like GitHub student, and you can sign up for a student account, which will get you a lot more things. So public, I don't want to initialize it. I'm not going to add a Git Ignore because I already have a project created. I'm going to create an empty project over here on GitHub. So my description might be, ECS36B demo GitHub repo. I'm going to go create my repository. And so GitHub is going to give me this URL. And this URL is what's going to allow me to associate my repository that I have locally with my repository that I have on GitHub. So let's go associate those two things together. I think I go to version control and I go to Git and remotes. So I want to add a remote. So that URL that I took, generally like origin is the name for like the remote repository, but you can name it whatever you feel like. Just the standard is origin. Just like in Python, you have like the self pointer, self reference. You can name self whatever you want, but it's just common for it to be called self. So we're going to keep this as origin. So we will put our URL there, say OK. And great, I've now added that remote repository. So later on, I can go put my changes there, which I'll show you how to do in a minute. Any questions on what I've done so far? So one thing that you might want to do is you might want to get changes from the remote repository. Git fetch will just fetch the changes, but won't try to integrate them into your program. Git pull will fetch those changes and then try to integrate them in. For C-line, fetch, version control, git fetch, pull, version control, git pull. Yeah, I said what they said to do on the right. Pushing is how you get your information from your computer up there onto GitHub or wherever your remote is. It's git push, and that'll push the current branch. And then version control git push will push it up to the top one. So we'll go do that right now. So I want to make sure that I'm on my main branch. Branches master. Okay, I'm on there. And now I go version control git push, Control Shift K. You're going to choose what the name of the branch is going to be on the remote server. So in general, that one is called master, but you can call it whatever you want. And it's going to be pushing my initial commit that I had. So I'm going to say push. And then I wait. You can see it's pushing down here. Then after that's done, my code will be on GitHub. Okay, great, it's done. We go back to GitHub. And I refresh this page. Hey, look, my files are there. And if I wanted to push a different branch, I would switch to that branch and then I would do the push. So if I wanted to push my Spanish branch, you can see there's only one branch here, it's just master. If I want to push my Spanish branch, I can go version control git branches, and then we want to go to Spanish version, then check out. Oh, I must have put a new line in there. Git. Okay. Branches, Spanish version, check out. Switch, and now if I go to version control git push, that we made a Spanish version, and that'll go up there. So one thing that you're going to have to do quite a bit is merging. When you merge, you're going to be taking, so you'll be on whatever branch you want to bring the changes into. Then you say git merge that branch name. It's going to go take the changes you made onto that branch, and it's going to try to bring them into your project and incorporate them. If there aren't any issues with making those changes, it'll do like a fast forward merge, and then everything is just going to get updated. Sometimes though, you might have like conflicts where between the old version and the new, and between the version you're trying to bring in and the version you have, and you're going to have to resolve those merges or resolve those conflicts. This might also happen if you and your partner are both working on a piece of code, right? Your partner made changes to some function, you made changes to that some function, they push their work up there, you then go pull the work down, then you have to go make updates to your code based on the work that they've done. So if I go over here and I say like I want to switch, say back to my master, and then I say version control git branches Spanish version, and I say merge into current, it was now merged into there, and there weren't any conflicts because I just made subsequent changes to that file. They also will give you the option if you want to delete that old branch after you've merged it in. You can leave it around or you can get rid of it. I tend to leave mine around if I want to be able to go back to it in the past. Let's try to create some issues. So maybe we go to master and we go to main. I'm going to try editing it here. So printf. We made some changes. Sure. Added some problems to create a merge conflict. So GitHub has now updated that. And so if I should be in my master branch still. So if I go to version control git pull, I want to pull in master, and our strategy is just going to be default. So we're going to pull in, and you can see that, oh, hey, look, there's some issues, right? And you can see that Git has inserted these merge conflict errors in there. So head is what I currently have right now. So I have hello mundo, and then this is what I've tried to pull in. And so we have three different options. I can either take their version, accept theirs, take my version, accept yours, or I can merge and create some different combination of both mine and theirs. So we'll show you a merge because the other ones are pretty obvious as to what's going to happen, right? If I say accept theirs, I'm going to get hello class, I'm doing just fine. If I say accept yours, I'm going to get hello mundo. So we'll merge. And it's going to give you a very pretty thing. So like here's the line of code that's different. We want hello mundo, hello world. So do I want to accept from the left? Do I want to select from the right? And then here's the result in the middle. Or I should be able to just be able to take the combination of the two if I wanted to. There are times where you want both, right? And that's going to be my result. My result will be the lines from both of them, right? But I could accept mine, or I could accept theirs for that particular version of that one line that's wrong. Any questions so far? So then you would say like apply. Oops. Is it next one? Okay. Most of the time I'm working by myself, so. How do I get to the next one? Oh, I guess I probably have to like click on this and click on this. So I'm marking those changes as being resolved so that I'm happy and that they're all good. And then I should just be able to say apply. And then if I say have updated, oh, I probably have to go back to main and say add it again, but oh, do I just do the commit now? No, now I'm lost.
When
Hmm?
you
Hmm?
you just arrow and just
Maybe we have to go back to here. I don't know how to resolve this now. Yeah, that was probably what I was going to do. So I should be able to say git reset head. Okay. Let's merge. And so what does this button say it does? Oh, it'll put it over there. Put that down there. Okay. That's what I had before, right? Save changes and finish merging. Do I have to click on this? Apparently click on that button. Then you can say commit and, you know, merge branch of master, right? Conflicts main.c. Then we would say commit. And then if you want to, you can go and you can push it back up. So make sure you resolve all your merges locally before you push them back up. If you're doing on the command line and you want to accept your version or their version, git checkout -- ours gets your version of the file, and then git checkout -- theirs will accept their version of the file. You then go and you add all the files back in to say that you've marked the merge conflicts as being resolved, and then you proceed from there. Then you commit afterwards once you're done. So one other thing you can do that's similar also. So you can see like here's a little like pretty graph of like here's my initial, then I made the Spanish version over here and added some problems, and then we went back into the master. So rebase is similar to merge, but it's a little bit different, and it can be a little bit destructive too. What it's going to do is it's going to replay the commits from the branch that you're on onto the branch that you specified as the new base. Or you can think about it as trying to take where your branch is at and put it onto this new base. So if I link, you might have your current directory looks like this. This is your initial commit. Time is going on, and you created some branch over here at C3. You might be like, okay, I'm done with my experiment and I want to put it into master. So what you would do is you can do the merge, and now you're going to create this new commit that has as its parents the experiment and the master, and then this is going to be the combined results of the two. What you can also do is you could rebase, and so you could say, you know, check out the experiment, and then we're going to rebase experiment onto master, and it's going to replay those commits onto the end, and there won't be a C4 anymore. So it made my new base for experiment where master was at. You can see it looks a little bit different in terms of the pictures. I kind of am more of like the merge strategy crowd than the rebase crowd, but you can use whatever one you like more. But if you do rebase, you kind of have to follow this one rule. You only rebase on your local repository. Never rebase on any work that's been pushed up to your GitHub account or to any public repository where someone else can work on it. Because if you do and people start making edits to it, it's going to come up with a super complicated mess that's really hard to resolve and create a lot of like nasty merge conflicts and put your repository in a weird state. So local stuff, rebase as much as you want. Anything that you made public or put out into the server, never rebase that. So one thing that you might want to do is access an older commit. You can do Git Log. It'll show you the hash of the previous commits, then you check it out. Or in CLine, we can go down to the bottom, click on Log, and then take an earlier version. So if I go back to, say, like my initial commit, I can right-click on it and say, check out this revision. And great, I went back to my initial project where I made my first commit. And so I can get old versions of files if I want to. If I go back to my main branch, Git branches master out. If I want to get the old version of a file, I can right-click on that file, say Git show history. It'll show the history of that file. Then I can go back to, like, say, an earlier file, right-click on it and say git, not git, and then it'll get me that version of the file and bring it in here. I can say, like, git, hey, look, now I have the old version of the file in my current version of the repository. So again, like, you might have some old version, like, oh, I actually liked all this old stuff, let's bring it back, and you can copy that file back over. You might also be able to do some old work. You'd be like git checkout head. That'll reset the repo back to what the repository was when you made that commit at that point in time. Or in the version control with CLine, you would do git, and then I can say revert, and I can say roll back. No. But I made edits to this file. Check it out. What do I have to do? Git okay, there we go. I had to go to git reset head, and I reset my directory. Hard means actually like change the files too that we have inside the directory, and I wanted it to reset it back to what it was at the beginning of this commit. So some tips for using Git effectively, which I always fail to follow, so I'm not as good as I should be, is one, use a lot of branches. Whenever you're thinking about adding something at all or making any changes, make a branch for the thing that you're trying to do, right? And then once you fully finished adding in that new functionality, merge it back in. Make sure that each branch like only focuses on a single feature so you know what you're trying to accomplish with the work that you're doing in there. And if you do happen to get sidetracked and you're like, oh man, well I want to do this other stuff now, branch again and branch again and branch again until you're focusing on one topic at a time. You also want to commit frequently. You can only ever go back to a point in time that you committed at. So if you do large amounts of work and then commit, you're only going to be able to see very gross changes to your work because I can only move back those large chunks of time. So if you commit very, very frequently, you'll be able to have a very fine-grained control of the versions of the files you're able to go back to and get precisely back what you want. So you might want to say, for example, make a commit every time you finish a function or create a class because you have that very fine-grained control, that very fine history, and you're able to move back to that precise point in time where not a ton of things have changed and then you have to go manually edit stuff to get it to be back what you want it to be. You'd also probably want to pull frequently. The longer you wait to pull from your master repository, the more changes your partners are doing, right? And so the more complicated your merge conflicts are going to be and the longer it's going to take for you to figure out what needs to be done because your projects had to diverge a lot. Also, when you're done, push your changes back up so that other people can access them and be able to pull them in when they need it. And also communicate with your partner when you're working with them so they know what's going on and what you're trying to do. If you guys are both working on separate things, you won't really have any merge conflicts, which is nice, but life isn't always that good when you merge things back together. If you want some more information, there's the book that you read, there's the Git documentation, which is great, and then there's also a cheat sheet from GitHub about a lot of common commands. And then if you're ever like, how do I do that? How do I do that in Git, Google? And it'll pretty much tell you what you need to do. Someone has probably asked that question before, and you'll be able to do it again. Any questions on Git? Yeah. You mean creating a private repo versus a public repo?
Yeah. How do you make sure that
So when you create the repository, there are settings on it, and you get to control whether it's public or private. Which under collaborators, you can choose who's able to submit things on here. You go add them by their GitHub ID. You should also have the ability to make a project private. Yeah. Yeah, even if you're not a student. Does anybody know how I can flip my project to be private?
probably
Okay, then so you can flip it to be private. But when you create the repository, it gives you the option of whether you want it to be public or private. Anything else? Cool, then let's talk about Valgrind for a second, if you guys don't have any questions about this. So Valgrind is a tool that is used to help you detect undefined behavior in your program. So if you're ever like, man, my program works great, fantastic, terrific on my own machine, but every time I keep submitting it to Codathon, it don't work, Valgrind is the tool you should be reaching for. Valgrind only runs on Unix systems, and I know some of you guys have gotten it to work on your Macs through like Homebrew, I think. But for Windows, it doesn't exist on Cygwin. So what you're gonna have to do is go run it in a Unix environment. You can get your own, virtual machine, or you can upload your code to Codathon and run Valgrind there. And then there's documentation over here under user manual for like how to do things, but I'll show you the basic default command that you're gonna wanna run. So what you're gonna say is ignore all the stuff up here. It's Valgrind, then -- log - file grind results. You can, what? Down here at the bottom. So you can specify some file that you want to put Valgrind's results into, and it's going to go throw those results over in that area. Leak check equals full means check for all possible types of memory leaks you might have. Track origins means if you have any uninitialized variables, it's going to tell you where they came from. Show leak kinds, we want to show all the kinds of leaks that can happen. You then specify the name of your executable, and then you would say whatever other command line options you want, and then your program starts running. And so if you have to enter an input, you can like type it in, or if input also needs to come from standard input, you can put that input into a file and then redirect it into your program, have it run from there. When you do this, you should end up with something that looks maybe like, not that, maybe like this. This one is a good one. It means that there are no errors with this person's code. You freed everything that you allocated. So they had 3 allocs and 3 frees. So everything is good. So no memory leaks are possible. Valgrind is only going to check to see that no memory leaks were possible with that particular set of input you ran. So if the particular set of input you ran doesn't exercise the code that has the bug in it, then it's not going to be able to detect it. It's actually just checking as it's running. It's monitoring your memory. I probably want to show you an example of a file where things are busted. I know the student was having issues. So again, like for this problem, you're going to get, under submission, you're going to get this file, which is what I named it, open it in a new tab. And so this is kind of what some of the errors look like. So you might have something that says like 1 bytes and 1 block are definitely lost in record 1 of 14. So this means that, notice it says like the space was made at malloc at make line on main. What this means that, so main called, on main on line 35 we called make line called malloc. Malloc created space, the space was eventually lost, right? You didn't free it by the end of the program. The problem is not with this line of code. Even though you might think for some reason, oh, my problem is actually, you know, where I called malloc on line 28. No, it's not. You created the space there, right? Which is great and good. Sometime later when you were done with it, you forgot to free it. So the problem actually exists later on. So you're going to have to go hunt down, where did I forget to free this particular piece of memory? The definitely lost ones means there was a pointer to that particular piece of memory at some point in time, and by the time your program finished, nothing was pointing to it anymore. There's no way for you to free it, so you've lost some pointer along the way. This guy just lost a lot of memory, it looks like. And so you can see that this person, you know, lost, you know, 16,000 bytes worth of space because they forgot to free their space when they were done. You can also get some other types of errors. Oops, I want to look at memcheck. So let me zoom in. So there you might also get something that says like an invalid read or an invalid write. This means you're going to some location of memory that you don't have permission to. The size really isn't that important. It's just the size of the read or write that you're trying to do. So it depends on whether it's like a double or an integer or a character will affect the size. But the more important thing is where is it happening at, and this part right here. Sometimes it'll tell you that this part is this memory location has neither been stacked, malloc, or free. You have some random location of memory that you're trying to do to access, read from in this case. Sometimes it might tell you that you've gone like 5 bytes past a block of some size that's been dynamically allocated. That means you went like 5 elements past the end potentially of that memory access. Or sometimes it says you went 0 bytes past the end, which sounds kind of weird. So if like here's the end, here's 0 bytes past the end at this point in time. End, 0 bytes past the end. You're right after the end. You went 1 element out of bounds. It'll also tell you if you've a conditional move or jump or like arithmetic operation depends on some initialized value. This means this variable has been created and you didn't set it before you used it. So make sure you set it before you used it. Here's an example. Complain about system calls. It can also tell about like illegal freeze. So sometimes, which we'll learn about in C++, you can create space via new. And any space you create via new, you have to delete via delete. Any space you create via malloc, you have to delete via malloc. So if you try to create space with new but delete with free, Valgrind will complain at you because that's undefined behavior. Or if you create space with malloc and try to delete it with delete, it will also complain about it. Which is the next one. Sometimes it'll also tell you that you might have tried to, in this case, the person's trying to free memory that they've already freed. This address they're trying to free is 0 bytes inside a block of size 177 that's already been freed. So it'll be like a double free error. Help you catch that. Again, using the wrong function. That one you'll probably not have. Sometimes you might have fishy arguments. For example, you might have made a mistake where you called malloc or calloc or realloc with a negative value. Like, I want negative 4 bytes worth of space. Well, that doesn't make much sense, right? And Valgrind will complain about that. And then it'll also detect memory leaks, too. You guys have any questions about Valgrind? Yeah. Like what you can do is you can get to oh gosh. You can go to like the Codeathon editor and then get your code up that way and then test that code. So it doesn't like you can't really easily test code you've already submitted unless you get it like on Codeathon into the editor. Any other questions? So use Valgrind if you're having issues or bugs in your program. If you have segmentation faults, if you have undefined behavior, use Valgrind. It should helpfully direct you to the area where things are going wrong and give you a good starting point to figure out what you should be fixing in your program. I will see you guys all in class on Friday, and maybe eventually